In this hands-on, we'll explore data transformations with generators in Python. Let's begin with our first example, streaming log processing. In this example, we've defined a log class representing a structured log entry and a generator function called log transformer, which takes a list of log entries as input. Each entry is a comma-separated string. The generator function then iteratively processes these strings, splits them into their constituent parts, and yields log objects. What's notable here is the use of the yield keyword, which is at the heart of any generator function. Unlike a regular function that returns a single value, a generator yields a sequence of values, pausing after each yield and resuming where it left off. This makes generators memory efficient, especially useful for processing large data streams like log files. Moving on to our second example around genome pattern recognition, we demonstrate a simple pattern recognition scenario. Here, the function genome segment processor acts as a generator that processes segments of genomic data. For each segment, it identifies a specific pattern, in this case, a hard-coded string AGCT, and yields a tuple containing the segment and the recognition result. Generally, the ability to process one segment at a time without the need for loading the entire dataset into memory is a significant advantage in this use case. Moving on to our third example of stock price anomaly detection, we have a generator function called detect anomaly that takes a list of stock prices and identifies any significant increases, defined here as 10%, of a rise from one price to the next. This is a simple yet effective way to spot unusual patterns in financial data. The function, as you can see, iterates over the list of stock prices, compares each price with its predecessor, and yields a message if it detects an anomaly. Having gone through these first three examples to build our intuition around the problem, let's take things up a notch and increase the complexity of each of those scenarios a little bit further. For instance, in a more complex example of streaming log processing, we would process logs of varying formats using regular expressions and a sliding window approach to detect anomalies based on log frequencies and error types. Here in this example, we have an anomaly detection in logs function that's accepting log entries, window size, and threshold as arguments. A regular expression is being compiled, a double-ended queue is being set up, the log entries are being looped through, matches found, complex log objects created, compared against arguments, and anomalies yielded depending on those outcomes. Please feel free to take a look at the source code in your own time. It is provided in the resources section of this lecture. Along the same lines, in the realm of stock price analysis, we could use quantitative finance techniques employing statistical methods like mean reversion and standard deviation calculations to detect anomalies. Here we have a function, for example, called mean reversion anomaly detection that's accepting stock prices, a window size, and a z-score threshold. Prices are then being looped through, appropriate windows being calculated, their means and standard deviations subsequently being calculated, z-score calculated with the current price, mean, and standard deviation thereafter, and if the absolute value of the z-score is greater than the threshold that was provided to the function, this function, mean reversion anomaly detection, yields an anomaly message. In conclusion, generators in Python, as you can see, offer a powerful tool for data transformation tasks in an efficient, sequential manner that doesn't necessarily require all the data to be loaded into a particular place, typically in memory, at the time of processing. By understanding and utilizing generators in this way, we can develop solutions that are not only efficient, but also scalable and adaptable to various data processing challenges that you may come across in your line of work or in other areas that you delve into. Thank you for your attention, and let's continue exploring these topics in our upcoming lectures and hands-on sessions. See you there.